We have 20 minutes to talk about the Power BI engine, so that's going to be an interesting challenge. We'll start in 1 minute on time. We're still a bit away. I'll start a little bit. My name is Kasper Jonge. I'm a principal program manager in the Power BI team. As I said before, now it's time to start. So we'll start. Well, we're going to talk about the Power BI engine in 20 minutes. So there's a lot here to talk about. So what is the Power BI engine? In Power BI, all data comes from the model. It's actually already quite old. It's introduced in 2010 with Power Pivot. We already had the same engine there. It's using a column store database called vertipaq under the covers. And it's built and designed for interactive analytics at the speed of thought. Click, click, clicky, clicky, draggy, droppy, slicing and dicing. It contains a very powerful analytical formula language called DAX. The authoring is building a model with end goal of analytics. That's really the main key takeaway and the goal. In 2013, we added Power Query, M, to allow more and various data sources. The same engine, the same build, we built it once and it's actually used in many different places. It's used in Power BI, it's used in Excel, it's used in Analysis Services, Azure Analysis Services, SQL Server, all these places, it's the same build, it's the same engine. It doesn't always work the same everywhere because we turn off features. Like for example, in Excel, there are some features that are turned off due to back compatibility reasons. But it's the same thing. So let's go through all the steps that we need to go into the model. We'll start with loading data. Loading data goes through Power Query. Okay? Power Query provides the get data experience for Power BI Desktop, and it's providing, and this is important, consistent data access to a lot of data sources. This was an old slide. It had 48 data sources. I think we're now probably at like 150 or something, and more getting added. And you can even write your own data sources if you want. So, but the most important thing here is the consistency. So if you go into Power Query, it's UI generated. There's no code needed. Power Query will take care of the code for you. And it's consistent, whether or not you connect to some Hadoop Spark node or you connect to a CSV file or a SQL database. It's the same UI, you have the same operations. There are differences though, we'll get to that in a second. So under the covers, this is what it generates. Like it's generating some M script. You probably all have seen this, but almost no one has to write this because it's generated. You do actions in the UI and it automatically generates Power Query. So you do a remove and it automatically writes code that says table select column. You rename, it adds a new line in the M syntax, and you do filtering, it automatically adds name in the syntax. It's consistent. It's the same everywhere. Again, if you have an Excel file, a CSV file, or a SQL Server database, the UI is the same, the M script is the same. The end result, though, is not the same. The most important thing is query folding. And query folding is something that is a bit hidden away. You don't see it, again, because we want the experience to be the same for everything. So again, if you have a scenario like this, it tries to push work back to the data source whenever it can. So actually, this M code gets translated to this SQL query. You don't have to write the SQL query. We do that for you based on the UI, the things that you dropped, it automatically generates this. Of course, this is much better for Power Query, for us, because we don't have to do any heavy lifting. We just ask SQL Server to do the filtering, to do the renaming, whatever it is, and SQL Server will do the heavy lifting. It gives the data back to us. That's it. Done. That's great, but in a CSV file, we cannot do this. So then we have to load all the data into the CSV file, and then all the steps in there are going to get executed. And it takes performance, it takes CPU, it takes memory, all these things, especially if you have a premium capacity, things get interesting here. You can see if things are folded or not if you go into the UI. Actually, the data flows UI has much better UI to actually show you this. But if you go to a view native query, you can actually see the query that's getting written. So, some best practices. Of course, who doesn't know Roche's maxim, data should be transformed as far upstream as possible and as far downstream as necessary. Easy and simple, but it's not that simple usually. What it means, the clearer your data sources, the less work Power BI has to do. Okay? The less your premium capacity has to do, the less you have to pay Microsoft. Of course, you're paying it somewhere else because your SQL Server has to do the work or whatever it is, but not Power BI. So with folding, you can push down work to the data source as opposed to Power BI doing the work. No folding is CPU in Power BI, folding is CPU in the data source. That's important. Now, another important thing here is choosing the right connector / data source whenever possible. The faster the data source, the quicker it goes. So, especially in the beginning, it actually has died down probably a bit by now, but SQL Server versus OData. A lot of people wanted to connect to OData data sources, like some OData web URLs and things like this. It's really slow. And then they complain, it's slow. Yeah, but because the data source is really slow, there's not much we can do. So thinking about where your data source comes from, it makes a huge difference. Filter your data as early as possible. Another important thing, so if you filter data down, things will go fast. Expense operations as last. Okay, so now we've imported the data. Now we're going to store the data. When the data gets loaded into memory, it's getting stored into that vertipaq memory. You can choose. It's either direct query or vertipaq, direct query, imported mode. Vertipaq is fast and interactive, built for that interactive performance. Slicing and dicing. Direct query is always up to date. You don't have to load any data, but it relies on data source perf, and it's also not as expressive. You cannot write complicated DAX expressions. I mean, maybe you can, but then you get really bad performance. So, from the outset, always import the data. Use vertipaq unless you're really convinced direct query is the right way to go. So, design principles, performance, performance, performance. That's how we build it. That's what it needs to do. It needs to perform. Query performance is more important than processing performance. So we really optimize for querying and not for processing. This is different in, for example, multidimensional. So why is it so fast? The data is in memory. It's a column-based compression that enables billions of rows. So what it does is when you import data and it looks like this, it will look at the data inside and it will store it in a different way in memory. So there's a few things that are happening here. It looked at the data and it replaced the years with zeros, pointers to that data. For example, 2010 actually gets stored into what we call a dictionary. It gets stored and then the data actually points to that. So instead of storing 2010, I don't know how many times, we store it once. And then we point to it with a very small pointer, a number. And we do the same thing with the others, January, February, Jake, salespersons. We actually store pointers to that data. So all of a sudden, we store very little data. Of course, important here is that you don't want a lot of duplicate data, a lot of the same data happening. So that's what we call dictionary hash encoding. It didn't do anything with the numbers here. So that's the next step. There's two things that happened here. We did value encoding and we did bit packing. Well, let's start with the first one first, value encoding. You see the numbers, it changed from 523, 645, it changed. So what it did on the numbers, it found the smallest number and it subtracted the smallest number from all the other values. So all the numbers get smaller. You think, what does it matter? It actually saves a lot of space. Okay, that's what it's doing. With bit packing, we do something else. So instead, what we saw in the previous slide, we store 4 zeros, we actually store 0 that is repeated 4 times. So again, more, smaller, smaller, smaller. So what does that mean? Okay, so how data is getting stored? Data is getting imported into the model. It does two things. It creates that dictionary and it reads in the data. It's stored in segments and dictionaries per column. Calculated columns that you create are also treated the same way. Then we do some other things, like we create hierarchies under the covers. And these hierarchies are a leftover from MDX days. So if you want to use Excel pivot tables, we need hierarchies to operate. Because MDX asks for data in a sorted way. So we need a hierarchy. you can turn this off. So there's a property in tabular editor. You can call it, it's called isAvailable in MDX. When you turn it off, it won't generate a hierarchy for that column. For example, if you have a sales amount column in the fact table, you never need to use it to slice and dice in Excel, so you can just turn it off, and it saves processing time. It saves memory. So it automatically happens. Well, the same thing happens with another table that you have in the model. Now, the secret sauce of analysis services, why it can do slicing and dicing, is that we actually create relationship structures in the model too. So when you create a relationship to a different table, it actually creates data in memory. So it knows how to get data on the other table fast, because we want to do slicing and dicing. This is why we always tell people dimension tables are important. You drag a thing from dimension table and a fact table for sales. Because of this relationship, this is so fast. SQL Server, for example, uses a almost similar version of the same vertipaq engine. It doesn't have this. This is why inner joins are slower in that side. Okay, then you create partitions. There are a group of segments that is more for management purpose. So some people think partition elimination is a thing in analysis services too. It's not. Only SQL Server has partition elimination. We don't. Yeah, and then you can create multiple partitions as much as you can. Okay, so best practices. Because of this, you can model the data in a star snowflake schema. Okay, that will help you save compression. Turn off auto date times. Patrick and Adam showed this a really good example of auto date times. Auto date times can potentially eat up a lot of your memory without you even knowing things are happening. Turn off isAvailable in MDX if you don't need it. And only load what you need, right? Everything takes memory. So consider the cardinality of the column and do you need them? Like we showed, the more of the same values you have in the model, the better it compresses. So date times, GUIDs, ID columns, they all don't compress that well. So really think about it. Like date time, if you split them up in a date and a time field in two different columns, it compresses like 10 times better. So vertipaq analyzer, you can use to take a look at your model. And then you can see things like here, I'm showing you. Like the auto date table has super high cardinality. It is really big in the model. It's like 10 times bigger than the sales fact table. So there's something wrong here. It's bad data. And you can go fix it. One of the best ways to figure out what's going on is to run the best practice analyzer. So Michael Kowalski in our team has written a tool called the best practice analyzer. You run that inside of tabular editor, and it scans your model for, don't be afraid the first time you run it on your model. You're going to get a lot of messages, but it's really useful, and you don't have to fix all of them because some of them are around like naming conventions and things like this, which are a bit arbitrary, of course, but there's a lot of things in there that really talk about the model itself and optimization, things that you can do to optimize your model. All right, 5 minutes left. The model and the relationships. So this is another interesting part. Relationships are very important. The way that you store data in the model is very important too. So imagine we have a model like this, where you have internet sales, customers, geography, product subcategory. So let's say we create a visual. I like these really old slides. This is the Power BI designer. Long time ago. This is still slides from that time. But nothing really has changed in this area for that. So you drag in English country and region name, and then you drag in sales amount. All of a sudden it just worked. It just worked. It's magic. Like you didn't write anything, it just worked. How did it work? How did it figure out that in Canada we have 1.9 million sales? Because it applied the filters and then it summed the sales amount on the remaining columns that are left. What does that mean? Let me show you. Data flows from the dimension tables or snowflake into the fact table. So we created that filter, country region name is Canada. It has 655 rows. You see Canada, we're getting repeated. That's the value we had showing in that pivot table. That data now gets pushed into the customer table. So now it's filtering the customer table. So the customer table went all of a sudden from 18,000 rows to 1,500 rows. Because we're filtering it for the particular context that we're in, the row that we're in. Now, that thing goes down too. It goes into the internet sales table too, and now it filtered the internet sales table where country name is Canada. Of course, it didn't really filter down to country name is Canada. It filtered for all the customers that are filtered by country name is Canada. That's how it's filtering down. So now the internet sales table is 60,000 rows. But it's getting filtered down to 7,620 rows. And on these 7,000 rows, we do a sum of the sales amount. Okay? That's how it's left. Now, this is important to think about for several reasons. The DAX that we just ran, in this case it's the sum of sales amount, only had to run, instead of on 60,000 rows, it ran on 7,000 rows. Much faster. You didn't have to do anything. You just created filters. You created a nice dimensional model that took care of the filtering for us. Okay? This is important. This is why we always keep talking about you need to do dimensional modeling, you need to do dimensional modeling. Because we came down to that. And that's the end of the road. It stops here. Until we start talking about bidirectional cross-filtering, then things become different. I won't go into that. That's 20 minutes on its own. Yeah, so that's how filters and relationships work. So all of these tables are not filtered. So the country name is the only filter here in this case. So we'll talk about the last part. 2 more minutes or something, 3. Relationships are important. We've loaded the data. Now we're going to query the data itself. Every DAX query gets answered by the query engine. The formula engine is the DAX calculation engine. It can answer any DAX. It is single-threaded, so scaling is hard. The formula engine calls in the storage engine to retrieve data. Simple logic is pushed down to the storage engine wherever it's possible. The storage engine scans vertipaq storage and returns results. But if you have direct query mode, the storage engine actually creates SQL queries that's getting sent down to the underlying data source. A vertipaq query executes in parallel 1 core per segment, optimized for execution. It has caching. The most important takeaway about this one is make sure you keep your DAX as simple as possible, because you want to open up DAX Studio and see more storage engine queries than formula engine queries. And that is the reason for you to simplify your DAX expressions. Now, again, I think Alberto did a whole pre-con on how to do that, so that takes a bit longer to explain. But in general, if you open up DAX Studio, there are a few tips to do this. Iterate over the dimension table, not the facts. Again, for the same reason we talked about before. Why dimensional modeling is so important. If you put a filter on the dimension table, the fact table automatically gets filtered down. You don't have to write DAX yourself. You execute your DAX queries over a smaller set of data, which is better and faster. Filter dimensions, let the engine do the work. Filter against the column, not the table. We see a lot of people who write filter table, and then the whole table has to be moved in memory. Who knows how wide the table is? Probably you can get rid of actually saying filter values of a particular column and then do your action on top of that. Use DAX wherever possible. Don't use DAX to fix your modeling issues. That's probably number 1, right? I call it like DAX gymnastics are needed because we didn't fix our modeling issues. And learn to use DAX Studio. Open up your model, debug, fix, rinse and repeat until you're happy. Take a look at the first one, use the performance analyzer to see what was the baddest query out there, the measure. Open it, look at it in DAX Studio, you can see, I mean, it's a bit hard to see, but formula engine, storage engine, fix, rinse and repeat. And with that, I am at time. 2 minutes left, okay, great. So that's it. Are there any questions? I know this was a lot to talk about, yeah. There's no vectors in vertipaq, the way I understand. I think we need this. I can't hear you. Sorry.
Does it use the vector instructions in that are new in the Intel CPU cores and the AMD cores?
Whether or not use the vector, I don't think so.
Okay.
I don't think so. There is works always going on to improve how it actually runs under the covers. Like it is C code written, so it's not running in assembly, but it's C code written in the engine. And the most interesting thing is it always changes, because especially now that Power BI is running in the cloud, we actually don't know exactly what chipset we're running under. So it has to work under a lot of them. All right, thank you. Any other questions? Yeah, there's one question there, and then we're at time.
Do any reordering if you've? Oh, sorry. Does M do any reordering, or the engine do any reordering if you've done something suboptimal, like sort followed by a non-related filter or something like that?
So does it do any reordering? You mean when you're importing data?
Yeah.
It does not do any reordering itself. So you have to order. You can order it yourself. It might give you some performance optimizations. Marco and Alberto actually have a blog post on this, but it's like not that important.
Okay.
So you can order it yourself. If you do an order buy, it might help you with get some performance gains. All right, that's it. I'm at time. Thank you very much. I'll be here for more questions.